Okay, here we go. Number one. Do you have a thought about problem number one? The whole front page is solved. Okay, so we're going to be finding x equals for the whole front page. So do you have any ideas? What are you going to do with number A? You're going to loop-de-loo it. Of course you're going to loop-de-loo it, right? We loop-de-loo all the time. It's our favorite thing to do. So if we loop-de-loo it, it's going to say 3 to the negative third equals x. And then our exponent knowledge kicks in. What does 3 to the negative third mean? 1 over 3. But I still have to cube it, so my answer is going to be 1 over 27. Right? Now, B. Please don't be freaked out. What does ln stand for? Log base E. 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 Right? ln E. So I'm not going to rewrite it. I'm just going to sneak an E in. That's my base. So now I'm going to loop it. So E to some power equals 1 over e to the 5th. Now again, use what you know about exponents. Doesn't that have to be a negative number since it's 1 over? And since it's a 5, I guess that negative number will be negative 5. So the answer to the problem is negative 5.
Is it because the e's cancel? Or does it not cancel because it has an exponent?
Yeah, nothing's canceling in this problem. We got to figure out what power we're going to raise this to get 1 over e to the 5th. It's going to have to be a negative to make it 1 over. This right here is e to the negative 5th. So x has to be negative 5. Nothing cancels in that one. Okay. Log base x of 19 equals 1. Again, don't freak out, loop-de-loo it. What's it say? X to the first equals 19. Well, x is 19, isn't it? 19 to the first power, so x is 19. Oh, the next one's so easy, I'm not even going to write it down. What's the next one? Loop-de-loo it. What's it say? 5 to the second equals x, and 5 to the second is 25. E, you're going to loop-de-loo it, but before you loop-de-loo it, you're going to have to remember what? There's a 10 in there. So 10 to the x equals 1,000. Then you're going to think about, okay, how many 10s do I have to multiply to get 1,000? 3. So x is 3. F, another really easy one if you haven't paid attention. What's the answer to F? 36. Yep, that's a property. That's 36. And finally, G, another loop-de-loo. 4 to the x equals 64. So some of you know what this is, some of you don't. So you're going to be typing 4 times 4 times 4, and that's how many times it takes 3. It's 3, so x is 3. So on this front page, every single one of them is x equals. Your answer should be x equals a number. You're solving. Now, on the back side, we have some more exponent practice. So let's talk about how we're going to handle these. These are not logarithms. Please don't try to loop-de-loo and really weird here. These are just exponent problems. Alright, so what's the first thing that pops into your head when you look at 2a? First thing that pops in is it's gotta flip. And it's 16 over 1 right now. So it's gonna be 1/16 to the 3/4. Now what pops into your head? Radical? Because a fractional exponent is a radical. So this is gonna be the 4th root of 1/16, and then we're gonna have to cube it. Well, what's the 4th root of 1? 1. What's the 4th root of 16? 2. And then we cube it. That's 1/8. 1 times 1 times 1, 2 times 2 times 2. 1/8. Okay? Alright, what about this one? Flip it and make it 2 over 1 cubed. That's just 8, right? That's a lot easier. That's just 8. What about this one? No flipping. Some of you just flip when you see a fraction. You just start flipping things. No. Why am I not flipping in this one? No negative. No negative exponent. So I leave it alone, but because that's a fraction, I do have to do the cube root, right? Cube root of 64, 4. Cube root of 27, 3. So I have 4/3. But then I still have to square it. So 16 over 9. Okay. And then that one, that last one there, 5 to the negative second times 10. What's 5 to the negative second? 1 over 5 squared, which is 1/25, times 10 over 1, right? So 10 over 25, which reduces to 2/5. Okay? Write the equation, the exponential function containing these 2 points. Before we start, would somebody tell me what my equation is going to look like? It says write the equation. What is it going to look like? Y equals A times B to the X. Okay, 2-point problem. Everybody gets one of the points. Because what do we know automatically? A is 4. So Y equals 4B to the X. A is this guy right here, the one with the 0. That's your A. Now, how do I find B? That's going to take a little bit of work. Plug it in. So 16/9 equals 4 B to the second. Now, I know some of you really struggle with this fraction stuff. So what you can do, if you want, is multiply by 9. So that your equation is 16 equals 36b squared. Would you agree with that? And then you can divide by the 36. And then you don't have to do any math. All you have to do is square root. So what do we get when we square root both sides? B equals what? Square root of 16? 4 over 6, which will reduce to 2/3. Now, I'm not saying you have to find B that way, there are other steps you can go through, but you have to end up with B and you have to end up with 2/3. So your answer is 4 times 2/3 dx. So if you struggle with that, copy that other sheet and go practice it. Shooty cootie, I don't see you tomorrow, do I? Alright, well Sunday, get this out and work through some of these to refresh yourselves. Okay? Number 4, last one. This thing, growth or decay? Decay. What is the percent decay? 29%. Why is it 29? Because 0.71 is 1 minus 0.29. And what's your initial value? 62. Alright, so that's what's coming Monday. Alright, so according to my notes here, we're on, in our notes, we're on page 28 down at the bottom. Okay? So here we go. Darius, are you paying attention? No, you're not. Let's see. Macy, I don't have anything yet for you. I don't know what's going on. If you want to, will the message come through on your iPad or do you need your phone? Okay, if you would keep that in case it comes through, let me know. Alright, so log base 7 of 49 equals x. I'm solving this without a calculator. When we get to part 3, we're going to need a calculator, but right now we're going to try this without. Oh my gosh, that could be on your quiz on Monday. Because what are you going to do with it? Loop-de-loo it. That's what we do. We loop-de-loo it. And then because we're smart people, we know that x has to be 2, because 7 squared is 49. Log base 2 of x equals 3. Oh my gosh, another easy one. That's going to be 2 to the 3rd, so the answer is 8. We could do these all day. Alright, now this is a little worse, but not bad. This one says the log base 4 of x plus 2 is 2. Now, fundamentally, it's exactly the same as this problem right here. So you're going to loop-de-loo it. But when you loop-de-loo it, it's going to say 4 squared equals x plus 2. So 16 equals x plus 2, and x equals 14. I wonder if they're going to get any harder. This is pretty easy. Log base 3, 1 minus x equals 2. Don't be confused by the parentheses. You're going to loop-de-loo. And what's it say? 3 to the 2nd equals 1 minus x. So 9 equals 1 minus x. Now we're going to solve this carefully. I'm going to do it however you want. I'm going to subtract 1 from both sides. So 8 equals what? Negative x, which means x equals negative 8. I don't know about you, I'm getting ready for something challenging. And this is not it. This is not challenging. How do you think we might start? What might be a good way to begin? Divide by 2. So log base 4x plus 1 equals 2.
Can you also just multiply the x plus 1 by 2?
No, you can square it. The exponent, remember, is a power, but then I have to square root it, and I don't want to mess with that. So I always divide that out if I can. So 4 to the second equals x plus 1. Looks like x is going to equal 15. One more, it looks like harder, but it really isn't. Look at it carefully. What do you think might be a good way to start it? Subtract the 6. Okay. And then what? Divide by -3. And then what? Loop-de-loo. Anybody else get 32? Perfect. Wow, that was a really easy section, good warm up. Because now we're gonna need our calculators. So, yesterday, we had problems that looked like this. 3 to the x equals 27, something like that. And we were able to do those because 27 is also a power of 3. So we had a common base. We chose them both, remember, we chose them both sides into the same number. That is not going to work with problem A. Would everyone agree that getting a common base is out of the question? Yep, can't do it. So when you can't get a common base, the only way to solve the problem is to take the logarithm of both sides. So put a log on both sides. And then remember from yesterday, did you get your email?
Not yet. Still waiting.
Joe, it's been like 2 periods.
I know.
All right, he had to have his thing out during class because he was gonna get this important email. Oh, you guys. Anyway, the exponent comes out front. Exponent comes out front. Exponent becomes a coefficient. So now I have x log 3 equals log 7. And then to get x by itself, I'll simply divide both sides by the log of. And then I'll go to my calculator and I'll type that in, remembering that I have to close these parentheses when I type that in. We talked about that yesterday. So log 7 divided by log 3, 1.7712. Make sure that's what you got. So the issue here was we couldn't get a common base. So we can't figure out what that exponent is. So if we take the log of both sides, then it's not an exponent anymore, it's a coefficient. Right? And then I can solve for it by dividing. Hurry up, right up here. All right. Next. this one. Can you get a common base between 4 and 10? No, now I know what some of you are thinking. 2 goes into both. It does. But remember, when we say a common base, we mean you have to have 2 to a power. You have to have something to a power. And this is 2 squared, but this is not 2 to a power, right? So there's no common base. So what do we do when we have to figure out our exponent, but there's no common base? We take the logarithm of both sides. And the beauty of that is, then this guy is no longer an exponent, he becomes a coefficient. So it's x log 4 equals log 10. And to get x, we'll take log 10 and divide it by log 4. (1.6610). Manny?
Can you always do it like that, even if you do have a common base?
Oh yeah, absolutely you can. Now, the problem is, if it's on the no calculator part of the test,
Yeah.
you don't want to be sticking logarithms in.
Right.
But yeah, that will work all the time, all the time. We just want to talk about this rounding just to make sure, because I do take off for rounding errors. So this is what I got when I typed it in. 1, 2, 3, 4 decimal places. That is more than 5, so I'm gonna have to round up. It's a 9. What does a 9 become? A 10. All right, now, C has strange numbers, but that doesn't change anything. Try C on your own. Try C. Who's got an answer? Anybody? What you got, Vanessa?
4 minus 1, 4 times 1.
That's exactly what I got. Good job. Okay, are we all set there, folks? No questions about that? Okay, let's look at D. It looks a little different. Okay, it's a little bit different, but I think you know how to handle it. What are we gonna do first? We're gonna divide. We're gonna divide by 6 first. So we have 2 to the x plus 1 equal to 3. Can we get a common base between 2 and 3? No way. 2 and 4? 2 and 8? Not 2 and 3. So what do we do when we can't get a common base? We log both sides. And why did we do that? What is the absolute beauty of the logarithm? That thing up there is not an exponent anymore. Where does he go? Out in front. Now he's a quantity, so you want to have him in parentheses. He's a quantity. How are you going to solve this? Remember, your goal is x equals. That's what we're shooting for. What are you going to do? Divide by log 2. So x plus 1 will equal log 3 over log 2. Be careful. And then what? Subtract 1. That's right. So I'm going to go to my calculator and see what I come up with. So I'm going to take log 3 divided by log 2 and then subtract 1.5850. How's that sound? Good? As opposed to what? 49 goes to 50. Well, Chloe's already starting on the next one. Let's take a look at the second one. Chloe, I couldn't tell. What'd you do first?
First I wrote down log on both sides.
Okay. Cancel that. Time out. We don't take the logarithm yet. What do we have to do first? You've got to get rid of the extra number. We talked about this yesterday. I don't care if you're doing it by hand, getting the common base, or if you're doing it with the calculator. You've got to get rid of that number. So e to the x equals 200 over 81. Now, some of you have this terrible aversion to fractions, so the first thing you want to do is type that in and get a decimal. Don't do it, because then you'll have round off error, and it's not necessary. Okay? E to the x equals a number. Now, can I logarithm both sides? I can, but since the problem has an e in it, instead of LOG-ing both sides, why don't we ln both sides? If I ln both sides, remember, ln is another logarithm. It's just a different base. So I'm going to ln both sides. What?
You can't have the ln next to the e, right?
Actually, I love it when there's an ln next to an e, because what do? Cancel. So this is gone, and it says x equals ln 200 over 81, and that's all I have to type in. So ln 200 divided by 81.9039. .9039. Math is so cool. That is amazing. All right, let's do one more on this page. So, Jarius, what are we going to do first here? Our job is to solve this equation.
ln both sides.
No.
Subtract.
Divide
I have to divide by 17. So let me say this again, because this is going to prove very troublesome. We can never solve an exponential equation if there's a number out in front here. Okay, if the a is there. We got to get rid of it. And we always get rid of it by dividing. So we're going to divide it out. So now I have just e to the x equals 93/17. And I'm not worried about that fraction. I'm going to get it here in a minute. Now, Jarius, I'm going to ln both sides. And what's going to happen when I do that? That's gone. And x will equal ln 93 over 17. And my answer then is 1.6994. Yep, 1.6994. Now you might say to me, Mrs. Ford, can I always use LN? And the answer is yes. If I LOG'd this problem, I would get the same answer. It wouldn't be as easy because nothing would cancel, but I can use whatever logarithm I want. So you can LN every problem, you can LOG every problem, you can mix and match. I do recommend, if there's an E in the problem, use LN, because it makes it so much easier. All right, oh Lord, there's more. All right, so letter G. Okay, Jarius, we're gonna try this again. What is the first thing in letter G that I am going to do?
You're gonna divide by 50.
I am going to divide by 50. And this time, it actually works out nicely. Doesn't that just equal 200 over 50? I didn't do that over here because 200 over 81 is nothing nice. Nor is 93 over 17. But this one worked out perfectly. All right, now what? I ln both sides. It's okay. Yep, it's fine. I'm gonna ln both sides.
So that cancels out the ln and the e. And then would you divide by that, or would you put the ln
No,
four in?
no. The ln and the e are gone.
No, on the other side. Would you?
I
put
still
that-
have ln4 over there.
Would you put that into the calculator before you
No.
divide?
I would divide and then go to my calculator and do ln4 over 8.112. Now, Sammy, it really doesn't matter. What you can't do or shouldn't do is, let's say you went ahead and typed this in and you wrote down that number. And then you came down here and you typed in that number, then you have round off error. So as long as you're keeping it all on your calculator, it doesn't matter. I like to go to my calculator once, and so I'm gonna go one time and type this in. Like before though, close those parentheses after the 4. Did you get negative 12.3776? All right, one more. Do it. I'll wait on your answer. What did you get? 10.8578? Feel like we have those under control? A little bit ago, we were doing some log equations. Now, these are more logarithm equations. We may or may not need a calculator for these. I don't know. We'll just have to kind of wait and see. But these equations are a little bit bigger than some of the other ones we were doing. But we'll be fine. Yep, thank you. We'll be fine as long as we remember what order to do stuff. So what's one suggestion?
Do 3 minus 2, -1 divided, and then do
Okay, I have a timeout. Can I do 3 minus 2?
No.
Because why?
She's connected to the log.
The 2 is connected, so it's like having 3 minus 2x equals 5 or something. You would never combine those, right? This is the same thing. So no, we do want to clean things up for sure, but that is subtract 3 from both sides. That seems like a wonderful plan. So negative, don't forget the negative there. Negative 2 log base 6 x plus 2 equals 2.
Divide by -2.
Divide by negative 2. So log base 6 x plus 2 equals negative 1. Okay, loop-de-loo. So 6 to the negative first equals x plus 2. 1 over 6, so x plus 2 equals 1 over 6. Subtract 2. Now that won't be a radical, because that's not an exponent, right? That's just a fraction, that's just 1/6. So that's gonna be 1/6 minus 12/6, negative 11/6, yeah. Yep, common denominator, yep, yep. So a little more arithmetic there.
You guys did the portal for, 3.
Wait, what is it? This, we just got told that we gotta be really careful about all these kids in the class. It's done for 3. Yeah, but an email from a parent doesn't count, they say, I'm sorry. Let me see.
If they do it like after 10, when they don't send out an email, you have to go talk to them.
Okay. So, here's what I'll do, because I know I'm not very techno either. I'm gonna write you a pass to the office, and you need to tell, Mrs. Magruder, or ask Mrs. Magruder to email me. Alright, so you're gonna check out with her, and she's gonna email me and confirm that this is legit. Okay, so gather up your stuff. The rest of us have work to do. Okay. Alright, what am I ready for? I'm ready for B. Alright, here we go. Let's get a couple more of these done, guys. So, what am I going to do first? Watch it. You can do that. But I need you to be really careful if you divide by 3 first. Because if you divide by 3, you have to divide every single thing by 3. And what happens is kids will forget that. Okay? So my suggestion to you is, instead of dividing first, let's add 2 first. You can do it either way, but you have to divide everything if you choose to start that way. So 3 ln x equals 6. That's how I'd start. And then I'll divide, but now it's much easier because there's only one thing to divide. And then I'm going to loop-de-loo. So what do I have to remember? E. So e to the second equals x. And I think we talked about this yesterday, maybe not. E is fine. E is like pi. It can be in your answer. So your answer is just E squared. Unless there's some reason that you need a decimal, like if it's a word problem maybe, it's fine, just leave E. E squared. Uh-oh. Helping. How do we know that base is E? Because our teacher has told us that ln is log base E.
Yeah, but that the e to the second, like, do we just bring that second?
You do. E to the second equals x. Yeah. Yeah. We do all the time. It's our favorite thing to do. All right, C. What are we going to do with letter C?
Subtract 2.
Subtract the 2. And when I subtract the 2, I'm going to remember this is negative log x plus 1 equals 2. And then I'll divide by negative 1. So now I have this. Are we all good here? Okay, then what? Evan, then what?
And then what? We loop to move.
By handwriting, you can move with.
You think there's a 10?
There's a 10 right there, there sure is. So 10 to the negative second equals x plus 1. Charlie, what's 10 to the negative second? Almost 1 over 100. Remember, negative exponents are 1 over, so it's 1 over 10 squared. And then 1 over 100 minus 1, which is 100 over 100. So my answer is negative 99 over 100. That was C. Okay, you guys are doing great. It's almost over. Let's see if we can finish this page. I think we can. That'll be perfect. All right, so 5 log 2x equals 10. Jeremiah, step 1. Divide by 5. So log 2x equals 2. And then 10 squared equals 2x. 10 squared is 100. So my answer is 50. All right, we got 2 more to go. Work on those 2. I'll have you come up and put them on the board, and then we'll be finished for today. We all need to be doing both problems. You need to do both. Did you do both already? Okay.
Yeah,
Okay. Don't lie to me.
I didn't.
Someone did that yesterday and it ruined my life. You ready? We're doing it together. Perfect. Perfect. Let me get out of your way. I haven't done it yet.
You rewrite it. I thought you were gonna post
Oh wait, no, I know what I did. I did like 2 first and then added 3. Because then I got to 4.
Comfy?
Mhm.
Got
So
any big plans this
listen,
weekend?
just sit here and relax.
Then you would have to do this, this for this first, this is 7, then you divide by 2, 7 over 2.
No, but you can recopy it, yeah.
And then you
I
would
don't,
just
I don't know if it's in Canvas or not, but you can recopy it. Or here, I got it, take a picture of the blind thing.
Okay.
You can't have it, but you can take a picture of it. I don't know if it's in Canvas or not, because I don't know if it's in Canvas.
If I had ever gone back to the study.
I got 15 and 12. What about you? I got 15 and 12.
How'd you get 2?
E is 15, F is 12.
I got 4 and.
No, this is 2.
You got
Oh
one?
my god, I'm
Yeah, I got 4 as well. And then I got 3.
I get 15.
You got furniture too, like painting the whiteboard?
Are you guys done?
We need a big
Here.
Wait, dress code.
But 3 doesn't divide into 7.
I subtracted the 1 first.
So who's gonna tell me I had to subtract the 1? So that's why the first year I didn't get, I got 12 because I didn't add the 3 of it.
All right, we're almost out of time, we need to talk about these, guys. All right, let's talk about it. Manny got, what did you do? Manny got 4. Everybody else get 4? Problem E? No issues? Now, F required a calculator. Because first they added 3 and got 7. Then they divided by 2 and got 3.5 or 7 halves. Then they loop-de-looed, and what did it say? 3 to the 3.5 power equals X. And no one knows what that is, right? So we get out our big girl calculator and we type in 3 to either 3.5 or 7 halves. And we got 46.7654. That's exactly right. How do we raise to powers? We use that little caret thing, right? So you type 3 raised to the 3.5, and you got 46. Right? Okay, good work, everyone. 3.5 is a monster section, so we're not done with it yet.